Today we're looking at a couple of examples on nested for loops. Each example is provided with a flow chart to to clearly explain the logic behind the solution to the example. Okay, now let's look at the first example or the first exercise. Okay, we have been asked to write a program to print every real number and character of a nested list, okay, on the same line, like horizontally, and each character should be separated by commas. Okay, and the problem says we should print an error message if the list has a nesting depth greater than 3. I would explain what that means later. Okay, now here is an example. So if we take this list for example, okay, this is a nested list, okay, and it's nested because nested list means you have several lists, or at least one list inside another list. Okay, so if we take a look at this is one list, one whole list, but when you get into this list, you can see that this is one element, okay, but this element itself is a list. This is an element, okay, this is a string, and this is an element, this is a number. Okay, and what we want to do is print every element individually. So we want to print 7, 0, 4, 8, Y, E, S, and 6.6. Okay, so if we write this program, this is what it should look like. I mean, okay, if we write this program and run that program using this as an input, this is what we want to get. Okay, I have put this image together just to explain the concept of nesting. Okay, now to visualize what nesting is, I would like you to think of this scenario. Okay, so let's assume we are looking for keys, okay, a set of keys or a couple of keys. Okay, but these keys are in a house. Okay, so we have been told that, oh, if you go to that house, you definitely find your keys there. Okay, but in this house there are several rooms. Okay, so the house is is a list. We can assume, okay, that the house is the main list. Okay, and each room of the house is a sub list. Okay, so that alone is nesting because there is a house and there are several rooms. Okay, but again, we have also been told that if we go to a room, we can either find the key lying on top of a table or in a box. Okay, so this also is another level of nesting because we are in the room, but we need to look in a box basically to get the key. Okay, so that's nesting for you. Okay, so if you were to look for the key, what you would do is you enter the house, enter one room, for example. Okay, look on top of the table. If you don't find if you do not find the key on top of the table, you look in the box. Okay, if you do not find the key, you get out of that room, you go into another room, so on and so forth. So that's basically the program we want to write. Okay, so if we use this example here, okay, so you would see that this rectangle, this purple rectangle and this blue rectangle, they make up the first layer of the list. Okay, so because you can see here, you see 7, 0, 4, 8. Okay, so that's one element and we can represent that by this rectangle here. Okay, then yes, here we can represent that by this rectangle, okay, and this by this rectangle. Okay, so now let's say we were to write the program, okay. How would we go about writing that program, basically? Okay, I have put together this flow chart. Okay, a flow chart is just a graphical representation of the logical sequence of any process. Okay, but here the process in question is a program. This is what programmers use, software engineers use. Okay, in our case, we have been asked, okay, we have been, limited to 3 layers. Say if the list has more than 3 layers, we should generate an error message, okay, meaning it's not supported. Okay, so what I have done here is I have colored the tasks. Okay, so each block here is a task, okay, and I have colored them differently. So the pink are tasks that are executed only if you're in the first layer. Okay, blue means you're in the second layer, and orange means you're in the third layer. Okay, the green tasks are just shared by all the layers. Okay, now let's see. Okay, so this is this is just start, meaning you're starting the program. Okay, and here is input. So for this program, what we need as an input is the list, the nested list. Okay, and I have just named it input list. So okay, to understand this, let's assume we are dealing with a simple list, meaning there is no list inside another list. Okay, let me give you an example of a simple list here. So let's say we just want 6, 7, that, okay, and 9. So this is a simple list. Okay, there is no list inside this. There is no multiple element string in this, so it's very simple. Okay, which means it has only one layer. We don't need to think about all of these. Okay, so basically, if you were to do this by hand, not the computer at all, you were to take one element after the other, what would you do? Okay, so you take the first element, basically, which is what this block is saying. X is equal to next element of input list, meaning just take the first element and assign this to X, meaning you say, okay, this variable is called X, this element is called X. Okay, the next thing you need to check is, because we have been told that we want to print every single element. Okay, so you need to check if this is numeric. Okay, meaning if it's a number, because that's what we have been told. If you say we should print every number and character. Okay, so is X numeric or a string of unit length? A string of unit length meaning this string has only one character. For example, like Y. Okay, that's a string of unit length. It has only one. If we had written YE, this is no longer a string of unit length. Okay, because it has 2 elements. Okay, so if the answer is yes, what do? You print, because you have met the, this has satisfied the criterion. Okay, you print. Okay, after printing, what would you do? You go to the next element, right? So what the program does normally is, it's you're like asking, have all the elements in input list been covered? Meaning, have I printed all the elements in this list? So if the answer is yes, meaning you have finished, you end. Okay, if the answer is no, you go back and take the next one. Okay, so you do this until you cover all the elements in this list. So it's as simple as that. Okay, so by its very nature, you can see that you are doing the same operation over and over again. Okay, and it's a classical, definition of a loop, because a loop just means you do the same task or the same operation several times. Okay, so this is it. But now let's assume here that there are certain times when the elements are not single element, single character strings, or they're not numbers. Okay, maybe they are lists. Let's assume in this case we had another list inside of this 0. Okay, so we follow the same approach. We come, okay, we start input list. Okay, we take the first element x. Now we check, is x numeric? In this case the answer is no, because x in this case will be this list. Okay, so it's not numeric. Okay, then, or is it a string of unit length? No, it's not a string. Okay, so in that case our answer is no, so we don't print, so we branch off. Okay, so when you branch off here, what you're doing is, it's almost the same as what we did here. Okay, so you branch off. What you do is you enter into that list, because this tells you that it's a list, or it's a multiple character string. So you enter into that list, you take the first element. Okay, again you do the same thing, you check, is y numeric or a string of unit length? Okay, if the answer is yes, you print it. If the answer is no, you go back and take the next element. Okay, okay, let's forget about the no. Okay, so let's deal with the yes first. Okay, so if it's yes, you print it, and then you go back and take the next element. So you do this until you have covered all the elements in that list. Okay, and what do you do after covering all the elements in that list? You go back to where you started, meaning you go back to the previous. Now let's assume here in this case you encounter an element that is not numeric, meaning this element has more than one character. Okay, so again you do the same thing. Okay, you take the first element in that, you check, if it's a number you print. Okay, and you do it. So it's like you're repeating a sequence. Okay, so this is one for loop, this is another for loop, and this is another for loop. So that's why it's called a nested for loop. Okay, but on this occasion, okay, because you can see that this is layer 1, layer 2, and layer 3. Okay, and we have been told that we should print an error message if the list has more than 3 layers. Okay, and so in this case, if you check and the answer is no, meaning if it's not numeric, or if it's not a single string character, then you print an error message, because it clearly tells you that it has more than 3 layers. So you print an error message and end. So that's just it. Okay, so now let's see how this is implemented. Okay, and the implementation is just a translation of this thought process into a computer language. Okay, so now this is our sample input list. Okay, it can be anything, but this is just our sample input list. Okay, so now what do we do? Okay, as you can see here, okay, we started with the first layer and then went to the second and then the third. Okay, so the same thing. So here we start with the first layer. So first layer. Okay, we loop over all the elements of the first layer. Okay, and how do we do that? We have, you have dealt with simple for loops. So this is just it. So we say for x in input list, because input list is our list. Okay, and x is just a variable name. You could use I or j. Okay, but what this statement does basically is it's going into this input list and accessing every element individually. Okay, so we go, so you take the first element, say x is any random element here. You check if x is numeric or a single character string, as we saw in the flow chart, and this is the syntax for that, because type x equal to int means it's an integer, or type y is equal, because okay, now let me explain this. Okay, there are three numeric types, three main numeric types in Python. We have an integer, we have a float, and we have a complex. Okay, and what the question is saying is that if the element is a real number, yes, I think here, okay, if it's a real number, so which means it's not complex. So we could have written this in two ways. We could just say if type x is not complex, okay, or what I did here was just say if type x is an integer, or it's a float, okay, or it's a string. So you see, let me explain this. Okay, so this is saying type x is an integer or it's a float. Okay, so these two answer the first question, that we print every real number. Okay, if any one of these is satisfied, then it's a real number. Okay, but if they are not satisfied, we want to print a single character string. So which means we want to check that this is a string and it has only one element. So that's what this statement is doing. Okay, if our answer is yes, then we print it. So, and this statement is just saying print x and separate this with a comma. Okay, if that's not true, we go to the second layer, because that tells us that this particular element x has multiple elements. Okay, and since it has multiple elements, it means the elements in x are in layer 2. So that's why we go second layer. And again, we did the same we do the same thing we did here. We loop over all the elements in x, okay, but here we are just naming those elements y. So that's why I said for y in x, again we do the same thing we did here, but instead of saying x, it's y, because y is now an element in x. Okay, again we check if it's an integer or a float, and if it's a single element character, a single character string. Again, if the answer is yes, we print y and separate, put a comma after it. Okay, but if y is, if y does not meet any of these, or y does not meet this criterion, basically as a set, then straight away we know that it has more than one element. So we go to the third layer, the next one. Okay, again in the third layer we loop over the elements of the third layer. Okay, so we loop over those elements as we did in the initial, in the first one, but here now our new list is no longer input list. Our new list is now y. Okay, because here, as you can see, we were actually checking if y was a single was numeric or a single element string. Okay, so y is our list, okay, and z is an element in the list. So again, we're checking the same syntax, nothing changes, and if it's satisfied, we print. Okay, if it's not satisfied, we raise an error. So this is how you raise an error. Raise exception is the command, and what you write here is just the message you want to write. So you can write anything. I can even just say no. Okay, and if we were to run this, okay, it's going to connect first. So you see, so now if you take a look, it's printing every element we have here on this line. Okay, so now let's say we want to throw in some error there. Okay, say, well, not an error, let's say here we want to put, okay, 0. Then let's say we want to put high there, and let's run. Okay, I think I have okay, let's say maybe I changed something not right. Okay, let's see. Okay, yes, I think it should have, yeah, good. Okay, now good, 0, let's say high, good. So now it should good. So you see, so it's saying, well, no, because it's raising an exception. Okay, now, and it's raising an exception because we want to support only a nesting to a 3 level, a maximum depth of 3. Okay, but here we have more than a depth of 4 basically, so that's why it's saying no. Okay, so now let's do one more example and see if Kelsey has something to take you through. Okay, so this worked. Okay, it worked, but there is an issue with this. Okay, it's inefficient in the very first place because you can see that we are repeating the same operation. So technically there is a way we could do this. We could do everything just from maybe one block. Okay, we don't need to repeat everything. So that's one thing. But let's assume we were asked to say we want to do this to a depth of 10. So which means there'll be 10 stages, and that's a little hard to do, right? So just repeating the same code 10 times, it's error prone. Okay, or let's even say there was an infinite, there was no limit on the depth of the list, which means we would need an infinite number of for loops to handle that. Okay, so clearly we could do better. Okay, so now let's see. Okay, so and for this we would need a recursive function. Okay, a recursive function is just a function that calls itself. Okay, so let's say a function is called A, okay, and you call that function to solve something, but at some point the function calls itself. Okay, and recursive functions are really a smart and easy way of handling some complex iterative computation or iterative tasks, like here. Okay, we could have a function, one function that is just doing this. Okay, and when we encounter an element that has more than one element, instead of doing this, we just call that function. So we just call that function, and the function will take care of everything. And if we encounter something again, we call that function. So and that'll be very, very efficient. So you would only need this and maybe one line here to call this function itself, and you're done, which is really smart. Now let's see how that works. Okay, and I have put together a flow chart for this. Okay, and again I have color coded. Okay, I need to edit this. Okay, let me see. Okay, I will edit this later. Good, great. Okay, so now let's see how this works, how a recursive function works. Just a few housekeeping stuff to do. Okay, these are you're dealing with 3 variables mainly. Nested list is just a nested list we want to analyze. Current depth is just where you want to start counting from, and by default it should always be 0 in this case. And maximum depth is just the maximum depth of nesting the program supports. Okay, so if you, for example, for the previous example, maximum depth will just be 3, and this is really cool because you can change the maximum depth, without rewriting the code. Now let's see how this works. Okay, and the principle is the same as the previous example. Again, you start and you input. Okay, you input the variables you want for the program. Okay, because every function requires input, like an input set. So for this, our input sets are nested list, current depth, and max depth. You know what these mean. Okay, this should always be 0 basically. Okay, so now, so you've supplied these inputs to the program. Okay, and the first thing you want the program to do, these are not included in the question. Okay, but it's just a good practice. Okay, so you want to check, because current depth, as I told you earlier, is just used to determine the current layer, okay, of the program. So if, for example, so let's say the program was doing this. Okay, so if it's here, then it will say, okay, I'm in layer 1. Okay, because you want it to stop when it reaches your maximum depth. Okay, so you need to keep track of where, or the program needs to keep track of where it is. Okay, so if it's here, straight away it's in okay, let's say here it's in layer 2, because this is the first depth, this is the first list, and this is like a list in a list, so it's layer 2. Okay, so, and one thing you should know about this is that these are positive numbers. Okay, because you're starting 0, 1, 2. Okay, they're positive numbers, so they should be positive numbers, and also they should be integer valued. Okay, you should not have layer 1.5, layer 1.2, or layer 2.2. So this block is just checking that the current layer you have supplied is valid. Okay, so it checks, is current depth a positive integer? If it's no, then it prints an error, because it means you have done the wrong thing. Okay, you the user have supplied the wrong input basically. Okay, so print error message and then end. Okay, so end means it exits the function, it exits the algorithm. Okay, so if yes, meaning this is a valid input, it also checks for maximum depth. Okay, meaning again, maximum depth again is just a layer, so it should be positive and it should be a whole number, an integer. You don't have depth 2.5, for example. Again, the same thing. If it's not an integer, if it's not a positive integer, then it prints an error message and it exits. Okay, end. Okay, so but if these are valid, then the next thing the the program does is that, okay, then it says, okay, everything is okay. Now let me enter into, okay, let me enter into the list, basically. So it's like saying, okay, they're like saying your keys, your stuff, okay, is in this room, okay, your stuff is in this, I mean, it's in this house, okay. But before you enter, you want to check that you have the right information before you enter the house, okay. So once you confirm that everything you need to find your stuff in the house, you know, is, you know, while you know everything you need to find your stuff in the house, then you enter into the house. That's basically what this is doing. So you increment the current depth by 1, because it means you have already, okay, entered into the first layer of the list. So that's what this is doing. So you increment. So if the current depth was 5, so straight away the program says, okay, now I'm in depth 6. Okay, so you're in this depth, okay, but we have a maximum depth that we should not go beyond. Okay, so you check, is current depth greater than my maximum depth? If it's, oh, I kind of, now I need to edit this, okay. But the problem, because you should have yes or no, you should not have 2 no's or 2 yes. If the current depth, okay, is greater than the maximum depth, meaning yes, then you print an error, because you have been told not to print anything beyond that depth. That's your maximum depth. Okay, so you print an error message. So this should be yes, and exit. Okay, but if the answer is no, which means you are well within your limit, then you do what we did earlier. So what you do is you take the first element in that layer, okay, you check, is that element numeric, you know, or is it a single element, I mean a single character string? If it's yes, you print the element and the depth. So it's simple. So it's, you know, it's just what we did earlier. Then you check, okay, have you covered all the elements in that layer? If the answer is no, you go back. So you do this until you have covered all the elements in this list. Okay, so after covering all those elements, end, you exit. Okay, however, if you encounter an element, say x, that is not numeric, meaning it's another list or is a multiple character string, then what you do is you call, so you see, you call this algorithm, this very one that we are discussing. Okay, so you just say call algorithm. So, and the only thing to note here is that when you call this algorithm, your new nested list is x, because you know it's x, that is your new list. Okay, so x, so you call it with these inputs: x, current depth, maximum depth. Okay, maximum depth is always fixed, current depth is changing. Okay, so it's simple. So you call this and you're fine. So that's why it's called a recursive algorithm, basically, or a recursive function, because it's calling itself. Okay, and it simplifies the problem. So now let's implement that. Okay, and how do you implement this? Again, this is simple. Okay, now I'm going to introduce you to functions, and it's not rocket science. Okay, so we want to define a function to implement this. Okay, and from this flowchart we know that there are 3 inputs, right? The nested list, the current depth, and the maximum depth. Okay, so now when defining a function, Okay, when defining a function, there are a couple of things you need to know. You start with this syntax def. Def always means you're starting, you're defining a function in this case, okay? And this is the name of the function. Again, you can use almost any name, okay? Unless names that are reserved in Python, keywords. But if you write any keyword, you will see it will have a different color. Okay, so this is the function name. We can even say Hindolo, it doesn't matter. And then these are the inputs to the function. Okay, meaning if someone wants to call this function, they need to supply these inputs. Okay, and every other thing is now the same. There's no difference. It's just like what we did here, but only here we want to enclose it in a function, and we are enclosing it in a function because we want to be able to call it recursively. Okay, and again, now let's see. Okay, how do we proceed? Okay, from this flowchart, what did we do earlier? We said we tried to check. So these are just basic error checks. So we do the same thing here. So we say raise an exception if maximum depth is not a positive integer. So you check if it's a positive integer. Again, how do you know? So you check. Okay, so type max depth. This is not. Okay, so if it's not an integer or it's negative, because negative means it should be less than 0, then it should raise an exception. You do the same thing for current depth. Okay, and as the flowchart suggested earlier, you increment the current depth by 1. So you just say this already. Now you check if the current depth is greater than the maximum depth allowed, which is just what you saw from the flowchart, and that's what this is doing. So if it's greater, you raise an exception. The same thing. And now this is the real code, and you can see how short it is, because everything we did there was just housekeeping, checking for errors, making sure everything is fine. And now what do? We just loop over the elements of the list. Here we assume that this element has only, this list has only one layer. So X in nested list. Again, you check if X is numeric or a single character string, and this is what that is doing. So if it is, you print X and you print the current depth. We just want to be able to see, okay, that this is correct, because we can basically compare the results to the input. Okay, so that's why we are printing both X and the current depth. However, if it's not a number or a single character string, so what do? We just call recursively, we call this very function, this function that we are writing, we just call it again. So you call printed list, but here our input is now X, just as here, no longer nested list. Okay, current depth is current depth and max depth is max depth. Simple. So this is the entire function. Okay, so what do you do after defining this? You have to run it. Okay, but when you run it, you're not going to see any result. Okay, because you're just like saving this function in memory. Okay, so it's now saved in the computer's memory. So whenever you call the function, the computer will just execute these code. Okay, now let's try to run it. Okay, let's we have saved the function already in the memory of the computer. Let's try to see if it does what we want. Okay, so this is just an example now. Okay, so this is our input list, and our current depth is 0, because we want to start, you should always start at 0, and the maximum depth here is 3. Okay, because you can use any number, but we have said we don't want to print lists that have more than 3 layers. Okay, so this is just defining the inputs, and this is how you call a function. So you write this function name, and these are the inputs. So you see inputs, you see current depth is an input, max depth is an input. See, so simple. So input list is just nested list in the function definition, current depth and max depth. So now if you run this, you see clearly that it's printing each element here and its layer. So it says that 0 is in layer 1, 1 is in layer 2, and 8 here is in layer 2. So you can basically check, if your function is correct. One thing I would like you to note is, especially those using desktop based IDEs, is that you should write, this and this should be on the same, should be written in the same script, so that when you run this, it runs this as well. Okay, in essence, really, you don't need to run this function call multiple times. You need, as long as it's saved in memory, it's there. You can call it multiple times. Okay, you only need to run it after, if you make changes to it. So for example, if I make any change to this function now, I need to run the function again, or else those changes won't reflect at all. But don't worry about that, we will do functions later. Okay, this is just so you understand how to solve that example more efficiently. Okay, we'll do functions later, so you can play around with this. So let's say we want the depth to be 1. So okay, now it tells you input list cannot have more than 1 layer. Okay, because we have said that the maximum depth we want to print from is 1. Okay, and our input list here has more than 1 layer, so that's why it's printing the error. So you can play around and see exactly what it does for you. Okay, so now let's say we want to run this for an infinite number of layers. So let's say we don't want any restriction. Okay, so if the list has 20 layers, it should print everything. The way to do this is simple. Just assign, so because the maximum length, maximum depth is just the depth beyond which the program should not print. Okay, so if you set the maximum depth to a very large number, then effectively it's like saying it should display, it should print from an infinite list. Okay, so again, it's simple. Your current depth is 0. Your maximum depth, you set it to any large number. I just use this as an example, but if you use this notation, because this notation is just saying 10 to the power 10, but if you use this notation, be sure to put int, because it's a float and it will generate an error, because the code is saying, well, this is fine, because initially I did say only integer, so it's fine. You don't need to change this one. You're fine. So now if you run this one, you see, so it will print everything for you. Okay, so even if you can add as many layers as you want, it will print everything from there. Let's see, you can 7. Okay, it's 9. Okay, 0. I'm just doing some crazy stuff. Okay, so this is pretty huge layers. So you see, so it prints. So I think this has 7 layers. So okay, so I think that's the end of the tutorial. There are more examples here, but it's just the same. So all you need to do is download this notebook, and you should be able to keep up. Okay, if I have time, I might explain this on video as well, and just share the link with you. But it's a very good exercise for you to to go through them, try and understand what's there.